Hello again. This week we're covering regression analysis, which is a technique that allows us to measure and test the effect of variables on each other. It dominates econometrics. Economists like to try and use regression analysis to answer pretty much any question. But it's also a very important technique across many fields, whether in natural sciences or social sciences. It originated with in physics. Trying to estimate what the true orbits of planets were, given they're measured with errors. Two chapters in the textbook cover this topic, the chapters 8 and chapters 10. 8 covers simple regression or univariate regression, where there's just one explanatory variable, and chapter 10 covers multivariate or multiple regression, where there are more explanatory variables. But really the two techniques are just one and the same thing, and they're not huge differences between them. So once you learn the simple univariate regression, it's not too hard to go on to the multiple regression analysis. The basic univariate regression will take many of the concepts we already learned in the course, like estimating parameter. Previously we estimated the mean of a distribution. Now we're going to be estimating the effect of one variable on the other, but it's the same concept. And also the concept of testing a hypothesis. So previously we tested, was the mean different to a certain value or not? And now we're going to be testing whether the regression parameter, the effect of one variable on the other, is different from a certain value, often 0 or not. So it applies the methods we already learned, and you'll see that these methods we learned, which maybe at the time didn't seem that useful or practical, actually have a very wide application once we transfer them to regression analysis. Multiple regression just adds more variables. The problem with the univariate regression, we're going to look at all the potential problems that can arise. One is that important things are left out of the model, so-called omitted variables, and these might bias the results. So multiple regression lets us include a whole lot of other variables that might be important, and hopefully improves our estimate of the effect perhaps that we're most interested in. The main issues involved in multiple regression, which are different to univariate regression, are first interpreting the regression coefficient, the effect of one variable on the dependent variable. You've got to interpret it as the effect holding all other variables constant, which is nice because that is like a controlled experiment, but a virtual one we're doing in our computer. But on the other hand, it can be quite tricky to interpret that correctly. Other issues that arise are, well, now we've got more variables, and what happens if they're really correlated with each other? So that's an issue we're going to cover. And yeah, and also going to cover some of the stuff that's in chapter 9 in this lecture about reverse causality. What happens if we think that, say, economic growth affects emissions of greenhouse gases, but in fact there's also perhaps a reverse direction of causality from emissions to economic growth. How do we take that into account, or what do we do about that? Anyway, we need to be aware that that could be the case. So that's one of the issues that's actually in chapter 9. And we're going to measure the problem of measuring variables accurately, which is not really discussed in the textbook, but as I said, it was the original purpose of this whole analysis, was to take into account the uncertainty due to measuring things inaccurately. So that is an important issue. One topic that is covered in the textbook that I won't cover is the so-called prediction intervals. That's discussed in both chapter 8 and chapter 10. You can ignore those sections. And another topic I will cover that's not mentioned in the textbook is the adjusted R-squared, which is used in multiple regression to take into account the fact we're adding more variables. Because the more variables we add to the model, the better it will explain the dependent variable, or supposedly explain. But there is a trade-off between adding more variables and actual explanatory power of that model, which we'll discuss in the lecture. So the adjusted R-squared adjusts the standard measure of the goodness of fit of the model, taking into account how many extra variables we've been adding to the model. What else? Tutorial session. Basically, we'll go over some of the concepts from a lecture and how they play out with real data, particularly things like reverse causality, and how we really should interpret regression analysis or not as a causal effect of one variable on the other. And then we'll also look at how to use regression analysis where we use dummy variables or categorical variables to use regression analysis to test the differences between groups in their mean effect, or the difference between groups in their regression effect on the dependent variable. So there's a couple of exercises in the tutorial that cover those issues. Okay, well that's it for this week. See you at the lecture and the tutorials.